Good morning, everyone. I'm very pleased to have a chance to present my software, MeteoInfo, and chat site. And I'm not a native English speaker, so maybe it's not so good of my pronunciation. First, you can see this website. So you can download the newest version from here. I suggest the Java version. The C# is very old. Also, chat is here. Okay. So my presentation is about MeteoInfo and its application in high-speed data analysis. I'm Yaqiang from Chinese Academy of Meteorological Sciences. So my content is about the first introduction, brief introduction of MeteoInfo, and then introduce the MeteoInfo map, this GIS desktop to display the meteorological data and spatial data. And also ChatStat is a trajectory statistic package, and MeteoInfo Lab is a scientific computation environment. So for MeteoInfo, it's an integrated framework both for GIS application and scientific computation environment. So it's especially for meteorological community. It has GIS functions developed from ground level, and it can open the often used in meteorological communities data sites such as NetCDF, GRIP, ARL, and has the JSON scripting ability. Also, it has scientific computation ability with multidimensional array computation, and has a 2D and 3D visualization. It can develop plugin, second development, and it's open source. Its code was in GitHub, and it's cross-platform because it is developed by Java. So you can see this is MeteoInfo map. It's just like a GIS desktop, and this is MeteoInfo Lab. It's such as MATLAB environment. Or if you have experience of Python, anybody have experience of Python language? Oh, okay. It's very similar with Python. It's a JSON. It's kind of Python. It's developed by Java. The typical Python was developed by C language. So it's a brief framework of this software. It has 3 parts. The core one is the MeteoInfo library. It's developed by Java. It's including the GIS functions and supported multiple scientific data formats such as NetCDF, GRIP, HDF, and has the multiple dimensional array computation and visualization. From it, developed the MeteoInfo map and MeteoInfo Lab. MeteoInfo map is a GIS desktop application. It has a layer-based spatial data view, has the ability for geometry editing and spatial analysis, scientific data exploring, and spatial map composing and output. So for MeteoInfo Lab is developed by Java and JSON, so it has a script ability, very like Python. So it has a numeric package. It's very similar with NumPy, and the plot package is similar with matplotlib in Python and other things. So this is the website of MeteoInfo. It's open source. The code is in GitHub. So many third-party libraries used in MeteoInfo include, especially for NetCDF Java library, it's developed by Unidate, and JSON engine included in the MeteoInfo, and also many others. So next, I will introduce the basic usage of MeteoInfo map. It's a kind of GIS desktop. So it is developed by Java, so it is cross-platform. It can be used in Windows, Macintosh, and Linux, and Unix. So it can use spatial and meteorological data it can be operational in a JS environment. It's layer-based. So for scientific or meteorological data site, we can think there's mainly three kinds of data sites. One is grid data, is such as the model output is grid data, and station data such as observation of stations, and land data such as the trajectory from high speed, and also other things. For grid data, we can create a counter layer, and shaded is counter shaded, and grid field, grid point, and if you have UV or wind direction, wind speed, you can create vector and bob layers. And also its raster is especially useful for satellite data site. And for station data, can create station point. Also, you can interpret it station data to grid data and do a counter shaded layer and above, and weather symbol and station model and the station info. There are some examples here. So this is the layer created from grid data. So it can be used the counter tracing algorithm to create the counter layer, and there's a shaded counter layer. It's a grid color, and also this grid points. This is, I think it's a raster, and it's a vector and a bob and a streamline. So it's normally used by Meteorological Society. For station data, you can create a station point layer from the data site, and also you can, if you have UV or other wind field variables, you can create a vector or bob layer, and the weather phenomenon. Yeah, it's weather phenomenon layer and a station model. So for station data, you can interpret it to grid it. In this software, it supports Chrisman interpolation algorithm and also IDW, interval distance weighted. So this is a trajectory output from high speed. You can plot a trajectory layer in a JS environment. And also this is a typhoon pathway. Also, you can write a very simple algorithm just from existing variables. So UV, you can create a wind speed and plot it here. Also, you can build the section plot and one-dimensional plot from the data site in this software. Also, you can mascot the content with a polygon. For example, this is a channel. Also, it includes a layout apartment part, so you can add the title and the legend and something else to. This is for publishing your data site in a figure for scientific journal or something else. Also, it supports some web map layer such as OpenStreetMap, Bing Map, and Google Map. This building is my institute in CMA in Beijing. And it supports many kinds of map projection, supported by Prod4J project. So such as this Lambert projection, Airbus, and Polystereographic, and Mercator, and many others. It also has some analysis functions of GIS, such as this is measurement of area on the Earth, and similar. Also, distance is selected the special point by a polygon, and it's selected by the attribute. So in GIS environment, every layer not just have geometry, but it also have attribute. It also supports some geoprocessing and editing processes and algorithm inside. This is a buffer and the convex hull, something else. Okay, thank you. So maybe I can do some demonstration of MeteoInfo map application. So how to okay. So after you download the MeteoInfo package, you just unzip it. It don't need to be installed, but your computer should have Java pre-installed, Java 7 or better. So after you install or you unzip the MeteoInfo, you have a MeteoInfo folder like this. It has some subfolders, the color maps, image, some library. Oh, how to transfer it? I'm not sure. But
yeah, maybe.
Okay. Oh, have to stop it? Maybe.
Yeah, you might have to stop the slideshow.
And okay. Got it. Okay. So library, including the third-party library, Java libraries, and also map. There's some shapefiles used in this software, and plugin. I will introduce after. For the chat stat is the plugin of MeteoInfo, and this is the MeteoInfo library, JSON library, and some sample data site, different kind of data site, and also toolbox for MeteoInfo Live. So you can see here, this if you are in Windows, you can use MeteoInfoMap.exe to open the software. If you are in Linux, you can use mmap.sh, and for Mac, it has mmap.sh to open the software. So after you opened, you can see like this. This is a meteorological data dialog. You can close it and open it here. So there are already some layers here. One is the country of the world. So you can expand it, and you can double click it. This is a polygon layer. So for legend, you can select this is a single symbol legend tab. You can double click it and select to fill, for example, to fill it with a different color and a different style, something else. Also, you can select a unique value legend style and select a variable in attribute. For example, it's a country name. So it with different country name is with a different color. Okay. You can export map with there's some room tools, and also this is for hand. Also, it has graduated color, so you can also select, for example, the population with a different scale of population with different colors, something like that. So go back to single sample without fill it. Maybe the color to black. Okay. So you can add some other shapeware as a layer. For example, in our tutorial folder, there is a maps folder. There is a states, United States. So we can open it. It's here. And double click and not view it. Okay, something like this. You can change the order of the layer. All of these 3 layers are polygon. Also, you can have layer as, for example, zode is a polyline or line string. So it's similar. You can change the style or color, something else. For example, okay, we can take it invisible. Also, you can have a point layer. Here, maybe not have. We can see in MeteoInfo folder. There's also have a map folder. There's a city around the world. So it's a point layer. It has similar. We can use different symbol and give it the size, for example, 10, and the fill color, the right one. Okay, and also we have the label. You can see this one. Select the city layer and give, for example, we want to choose the name on the map. So select the field of name and update. You can have Y offset or X offset of it. Okay, you can also, this is a longitude and latitude projection. So you can, from view, my projection, you can project the layers to other, for example, Lambert conformer. Okay. And many others. Just go back. Also, we can support the web layer. So click here, the map frame, and right click and add web layer. The web layer should be in Mercator projection. So it will property that you should project to Mercator projection. So yes. So default it's OpenStreetMap on it. So we could make it invisible. And you can double click it and select the web map provider. For example, Google Satellite Map. Okay. Also, because it's a JS environment, so every layer not just have the shape in it, also has attribute table. So select a layer and right click it. You can see attribute table for it. So you can see the information inside. Also, you can identify. There are also some other tools you can, for example, to give a text on it. You can select it and to change many things inside, and also you can delete it. And many others, for example, a circle. Also, you can add user-defined line and select it. Double click. There's some style. For example, it's a code front. Okay, you can right click and reverse. And also you can edit it, something like this. Okay. So there are also many other things I just skip, and this is just a demonstration. You don't need to follow me. Maybe I was too fast because of time limitation. So just the demonstration. You can do it after the class. So this MeteoDate dialog. You can if you close it, you can open it from here. It supports many kind of meteorological date sites. For example, the first one include NetCDF, GRIP, XDF, and many others. And grid date, and ARL is used by high speed. And high speed output, trajectory, concentration, and particle date, and ask test date. MeCaps is data format from CMA. It's used in China. And MF5 output date, AWX is a kind of satellite data site. For example, we can use ARI date. So we go to the tutor. We can find some ARI data site from CapText. For example, this one is global one. So it will read the projection information from the data site. If it's not consistent with the map view, if you project it or not. So we can not, and then we can choose the variable here. If we choose one variable, it can choose the time, the level, because it's a pressure surface pressure, so it's just one level. So if you select, for example, the V, it has many levels. So you can select the different graph type. For example, shaded counter. Just click draw the date. So the content, a new layer formed, and with you can see here. And also you can see the information of this site after you open it. This is the information. There's some dimensions and variables. Each variable has a different dimension, maybe. And also you can all of the layers created from the data site just in memory. So if you want to save it in your disk, you can right click it and save layer to, for example, for a counter, you can save a shape file and can be used in other software also. So also I can remove it. And another one is shaded. So you got a shaded layer. You can make it transparent. Just select all and double click one. Set transparency, for example, to 50. Okay. So the grid fill, it also creates a polygon layer, but with every grid with a rectangle and grid point. So you can see the domain of your model date. You can also for example, label it with a pressure. So it's a vector. It will find the u or v variable by software automatically, and you can change it from here. Maybe use a different one, and also you can skip if it's too many vectors. You can skip. So it's a bob. Also, you can set different colors, for example. Okay. And also, it can do streamline analysis. Okay, so can close it. It has a project file. So if you want save the project, you can open it again, and it will keep the projections and legend set and many things. So we will continue. Oh, I forgot to open other things. So we can try high-speed output dataset in this software. For example, trajectory. So we can not here in files maybe. T-dump, for example, this one. So open it, there's just one variable. I just plot it, and you can see it here. And it's very similar for the high-speed output concentration data with the ARL data. All of them are great data set. So I could find one, maybe here. Okay. Out of memory, anyway, maybe later. So we can continue. So next, there's some example. This is ARL dataset. This is the high-speed output dataset. This is a trajectory dataset opened by MeteoInfo, and this is the particle dataset. So we can go next part. It's about trajectory statistic package. It's named ChartStat. It's a plugin of MeteoInfo. So this is a framework of ChartStat. So it can use the meteorological data with a high-speed model. In fact, it uses high-speed model trajectory executable file to calculate trajectory. After the trajectories are calculated, it can create a trajectory shapefile and a layer in MeteoInfo. And we can add measurement data. For example, if you have a measurement station with very long-term observation, you can add your measurement data to the trajectory data, and it can do following analysis. Also, you can trajectory view and corral. First, you can do cluster analysis. It's also in high speed has similar functions. Also, you can do the this is the potential source contribution function. You can see the station, the pollution, where it come from, the source of pollution, and also CWT is similar, different algorithm, but the same purpose of these two analysis. So this is a plugin. After you you download the ChatStat package and just unzip it, there's a ChatStat folder. You move the folder into the MeteoInfo plugin folder, and then you can use this plugin menu to make it available in MeteoInfo. Such this is a result. It will add a menu in MeteoInfo with these sub-menus. So it can also calculate trajectory, but it used HySplit instead. So normally it's just for long-term trajectories. So it's very many trajectories together. So normally it's just for monthly calculation of trajectory. You can input year and month and the location. It's very similar with the HySplit interface to calculate trajectory and runtime and top of model, start over, and meteorological data files. Also, you can set how many days in this month you want to run. And you can see this is execute file. It is a high TS-STD. It comes from a HySplit model. You can set output and calculate month by month. After you got the trajectory, you can convert it to a shapefile. It can be added in MeteoInfo as a trajectory layer, like this. It's a polyline layer. It has the attribute of the date and height. So with this trajectory, you can also show the vertical distribution in 2D and 3D. And if you want to know the station, what's the pollution come from, which pathway, and where is the source of the pollution, you can do some analysis. First, you should add the measurement, station measurement date to the trajectory. It was according to the date and time of the trajectory and your observation. So there's an interface. You can open a measurement date. It's a CSV date format. You can select a date column and date format and which date field you want to add in. And after you add, you can see the attribute of the trajectory layer. There a new column. For example, in this example is PM10 concentration, one by one. For each trajectory, one row is a trajectory. So each trajectory has a PM10 concentration value. So after that, you can select the trajectory with the PM10 concentration. For example, you can create, you just want to see which trajectories with the PM10 concentration larger than 150. So you can create this kind of selection. Also, you can do a trajectory cluster analysis. It has been introduced yesterday. It's similar, but in this software, we have two kind of distance. HySplit use Euclidean distance, and also this software provide angle distance. I will tell it more detail later. So it can also produce TSV plot to help you to select how many clusters it should be selected. So after you cluster the trajectories, for example, there are 5 clusters here, 6 or 5 clusters here. You can add the cluster to each trajectory like this, so you can know each trajectory is in which cluster. So this is some different with high split. We have Euclidean distance. It's just the geometry distance from the XY. In fact, for the cluster analysis, the height of the trajectory was not used, just use the longitude and the latitude. Also, we have angle distance. In this, the difference of these two things is if you just want to know which direction the trajectory come from, it's better to use angle distance. For example, if two trajectory, one is very, very short, another one is very, very long, but they are a very similar direction. So it will be in same cluster in angle distance, but it will be different in Euclidean distance. So after you get the cluster result and you also have a PM10 concentration of each trajectory, you can get cluster statistic result. For each cluster, the mean value of PM10 concentration and how many are pollutant trajectory, the mean value of pollutant trajectory, something like this. For a PSCF and CWT analysis, first you have to create a grid layer. It's a grid polygon layer. There's an interface to select the extent of the layer and the cell size. This is in longitude and latitude coordinate system. You can select the type PSCF and or CWT, and this is the result. For example, for PSCF, you can create a layer like this, and it has an attribute with PSCF value, Nij, Mij, and WPSCF. So the PSCF means the potential source contribution function. It is widely used to see the long-term observation of the in a station where the pollution come from, to see the potential source of the station. It's very simple, in fact. The Nij means the total trajectory endpoints in one grid cell. So you have to set a value, for example, 150. If the PM10 concentration larger than it, then it is pollutant. It is less, it's clean. So the Mij means how many pollutant trajectory endpoints in that grid cell. So you just get the ratio of it. So if PSCF is larger, that means that grid cell may be the potential source of the station. So that is the algorithm. It's quite easy. So this is the interface. You should select the PSCF layer created from a last type, and you select a field. For example, in this one is PM10 concentration. You select the trajectory layer, and you have to set a criterion value. And you get Nij, Mij, called PSCF, and you have to weight it because, for example, in some grid cell, maybe its PSCF value is very high, but it has just 1 or 2 endpoints. So maybe it's not statistic significant. So we have to reduce the value of that grid cell. So we can set the weighted function of it. This is arbitrary, so it's experience. Maybe you have to try several times to see how to set it. It's which value is better. Also, you can weight by trajectory number. This is by endpoint number. Also, from this analysis, you can get the every grid cell, how many trajectories past it. So you can see the trajectory. For example, if one trajectory is short, it has maybe in one grid cell is many endpoints inside, but it's just one trajectory. So maybe it's also not so statistically significant. So we also need to weight it. The CWT means concentration weighted trajectory. So you know, for the limitation of PSCF is it's just set a criteria value. If the value is 200 or it's 500, it has the same value in PSCF. So CWT means it's very simple, also very simple. It's just the mean concentration value of the grid point, a grid cell. So you know, in each grid cell, there are many trajectory endpoints inside. So we have connected the measurement concentration to the trajectory. So we know each trajectory endpoint, the concentration of each trajectory point. So we just get the mean value of it in each grid cell. So we get this kind of value, CWT. The interface is similar with the PSCF. You can select the CWT layer and also the field, for example, PM10 concentration, and select the trajectory layer. And you know, for measurement, you maybe have missing value. Some days the instrument has broken, you have no data. So you can set a missing value. You have to write it here. So we can, the software can know this data will not be used in the analysis. Also, you can get an NIJ and just call CWT and weight CWT. The weighting function is the same with PSCF. So another demonstration of a chat stat. I have to end it first. So after you download the chat stat, for example, here, you just put it in the plugin subfolder. So I have put it in, copy it inside, and then you open MeteoInfo map. If there's no this menu, you can see the plugin manager. So if you first time you copy trajectory folder into the plugin folder, you will have no this one. Just this one, you have to click update. It will read plugin folder, and to find the plugin, it will find this one, and you just check it. If you uncheck it, you can see there's no trajectory menu. You can check it here. So now you have a charge stat plugin. So the first step is to load a default project. So you can see it's important because there are some layer group. So for example, in a geodate group, you have rivers, China shape, and this is the world country. If you calculate a trajectory, create a trajectory layer, the trajectory layer should be inside the trajectory layer group. So the following analysis will looking for this layer group to find the trajectory layer. It's same with the PSCF, CWT, and the cluster. So after that, this is a calculation. So in the MeteoInfo website, you can see the documents here. This is charge site. It's an example. So here, this is an example. We can follow this 05, 05. And 1977. Oh, 39, 77, 98.48. And 500, I think. The runtime, because it's a backward trajectory, the negative 72 and okay, 06, first one. So we should add meteorological field. I have sample field here. Oh, not here. We should open the meteorological date for May of 2005. Also, we need, because we do back trajectory analysis calculation, so we also need the meteorological field from April. So it's May, so we can do 31. So we select the output. Just try one. Okay, and just calculate. It's very similar with high-speed interface to calculate trajectory. I could see a little about the ChatStat folder here. We can see plugin ChatStat. It also has working. So you can see it's here. It's come from high-speed, and also has a body field. It can be used in trajectory calculation. So it has done. We could convert it to TGS field and combine it. Okay, old new one. Charge, test. So this field is just calculate. Just okay. So it has been transferred to .tgs field and was combined for 1 month for just one field. After that, we can convert to shape field from the TGS field. Oh, not this one. Computer, temp, charge, test. So we just calculated May of 2005. So it should be this one. So it was added in MeteoInfo as a polyline layer here in the trajectory layer group. So we can see the attribute table of it. It has date, also year, month, day, hour, and has heat, start heat of it. So next one is to we can choose the pressure profile of the trajectory. So we can click it and select one of trajectory. And you can, this is a switch button for 3D view. If you read this geodate layer group, inside the visible layer will be shown here as a background map. So you can see the 3D view of the trajectory. Okay, start. Okay, and the next we will add the measurement date to the trajectory. So we select input date. In trajectory, charge stat. Let me see. Okay. In your MeteoInfo folder, you can select. There's a sample date. This is a station in China, so northwest of China, Jiuquan. It's around the desert region, so you can select it. So we can see the date file of it here. We can open it. We can see it. First row is the name of the each color. So it's date and the PM10 concentration with the common. So we add it and select the date. This is if you want to add the measurement date to the trajectory, you have to make the date as same date at same date and time. The measurement and will be added to the according trajectory. So in this case, we have no end date, so it's null. So the format, you can see here, is year with 4-digit year, month, and day. So we select year, month, day. It's no hour. So this measurement come from China. It's in its time room is different. So we select the right time room to. Now we select the date field. It's PM10 concentration, and add date to this trajectory layer. Okay. So after it's being added, we can see the attribute table. You can see PM10 column was added. So each trajectory has the PM10 concentration now. So we can identify it. For example, this trajectory is a date, an hour, and heat, and PM10 concentration. So now we can change the legend of it according to the PM10 concentration, gradient color, and it's PM10. Okay, so with different PM10 concentration with different color, something like this. Okay, so we should remove it. Remove layer, because there's an example layer here. I think we use this one. This one is because there are some other trajectories. I don't want to calculate trajectory here. So we just add that layer. Okay, see samples. Sample here. It's Jiuquan, it's the station name, and you have to make it inside the trajectory layer group. So let me see if, oh, oops. attribute table. Okay, no PM10 concentration. We can do it again. Add it to trajectory and select this one and select the PM10 concentration, add it to this layer. Okay. So now it's added. So you can see it also have some missing value in this data site. We can set it a special data value. So after we added it, we can, there's a selection selected by attribute. Select this layer, trajectory layer. You can see this PM10. PM10, you can get value of its color. The larger than, for example, 150, and select. So the trajectory, or we call the pollutant trajectory, was selected according to it. We could clear it. Also, the trajectory could be viewed further. By its heat with a different color. So we can see each trajectory may have different color in different part because it has maybe in different lengths, it have different height of the trajectory, something like that. And also you can use PM10 and many others to do this kind of analysis. So just come back. Also, you can make the endpoint visible. You can see this a point sample, draw point sample. So you can apply. So you can see each endpoint was plotted in the on the trajectory. You can see the interview with this too many. For example, every 6 hours we put the endpoint on it, something like this. So we could go back. Okay. So after that, we could do a cluster calculation. So we have to first we select the trajectory layer. So we can set point in view. It's also similar in high-street cluster analysis. It also has an interview selection. If the too many trajectories and trajectories are very long, maybe it has a memory problem to calculate. So you can set the interview of the endpoints. Also, it will be read of how many trajectories in this layer, and it will read the first trajectory in this layer, how many endpoints of it. So for cluster analysis, each trajectory must have same number of endpoints. So we should do a checkpoint number of it. So this is perfect. All trajectories have same point number. All of them has 73 endpoint number. So in many times, some users call me that they cannot do cluster analysis. Many times it's just because some trajectories are not calculated correctly. For example, some trajectories maybe just have 60 endpoints. In many cases, it's because when you calculate the trajectory, for example, you do backward trajectory analysis calculation, you have the first day of May of 2005, you have to also add the April meteorological date because it's a back trajectory calculation. So somebody forget it, maybe the trajectory are not completely traced. If you have some trajectories are not the same trajectory with others, you don't want to recalculate again, you may ignore the data length with abnormal point number, but it is not suggested. So you have to set output fair For example, cluster TST. Okay, you can select the distance type, Euclidean or angle, max cluster number, and do calculation. Okay, it's quite fast. And view TS view. TSV is very similar with high-speed cluster analysis. You can say maybe 5 cluster is better. So we can select 5 and calculate mean trajectory. So we can give a name of shapefile, save file, just save it. So the cluster layer was added in cluster layer folder. So we can add the trajectory, add the cluster column to trajectory. Okay, done. So we can see the attribute table now. It has cluster, so we know each trajectory in which cluster. So we can view the cluster. So we can see with different color. It means in different cluster. So let me see the this is the result of a cluster. It has also attribute table. It has also has trajectory number, how many trajectories inside this cluster, and ratios of a total trajectory number. So you can add, for example, the ratios in it. Also, you can select the different color, each color cluster for each. Okay, we could, for example, it's more easy to be seen. We can select the label and move it to the better position to do this kind of thing, and you can output your figure, something like this. So this is the cluster analysis. After you get it, you can do cluster statistic. Okay, we have to select PM10, and criteria value is 105. Mason value is negative 199. So you can get the statistic result of the for each cluster, the mean value, mean PM10 concentration value of each cluster. So you can know which cluster is a pollutant cluster, something like this. Yeah. So you can see this cluster 3 is most pollutant with the highest mean concentration. So 3 is this one. So after that, we could demonstrate the PSCF and CWT analysis. First, we have to create a grid layer. So we use longitude, latitude. Okay, I have to check it. Distance. So we use this value, 65, right, 111. 3060. And grid seal is 0.5. First, we create a PSCF. Okay, we have to give a name of the shapefile. Okay, got it. You can see PSCF layer was added in PSCF layer group. Also, we can create CWT. Okay. So because this layer are on up of the PSCF layer, so you cannot see PSCF layer because it's heavy field. So you have to make it not draw fill. Also, this one, maybe you just make it invisible. So you can see this is PSCF value, PSCF layer. You can see the attribute. It has ID, and this column is number of trajectory. How many trajectories will pass this grid cell, and it's NIJ, MIJ, PSF, PSF. So you can do PSCF analysis now. You first select the PSCF layer and the field. We select PM10, criteria 150. I will check it. Oh, it's just nice one. Yes, 150. And the missing value. So after that, we should also select the trajectory. Maybe you have many trajectory layer here. You can select the right one. And first we get NIJ. That means get the every grid cell, how many totally, how many endpoints of trajectory. And then get MIJ, the pollutant endpoints, how many pollutant endpoints in each grid cell. So just the ratio call, so it's very fast. So we use just leave this value, weight it, okay. Now we can see, double click, change the gratitude color to WPSCF. We can see the result. So you can see the here value means that this is a possible potential source of the pollution to this station, observation station. So okay, that's done. We can do similar analysis with CWT. It's quite similar. Okay, missing value. For this one, you don't need to set a criteria value because it calculates the mean value of each grid cell. So first one, get NIJ, call CWT, and weight it. Okay, done. Also, we can change the legend to see the value, to see the result. Okay, so it's quite similar. Because at this kind of region, it's a desert. It's PM10 concentration. And this station is very near to the desert region, so its potential source is a desert. So that's all this demonstration. We need to go to next part. So next part is MeteoInfo Live. MeteoInfo Live is a scientific computation environment similar with MATLAB or Python with NumPy, Matplotlib, and many other packages. So it has several packages. The core one is numeric. It's very similar with NumPy. It has ability to do multi-dimensional array calculation. It has also table data to do the table data with columns and rows. And it has num module to do error creation and computation, and also some sub packages for fitting, interpolation, line algorithm, and random and statistic analysis, something like that. Also, it has this site sub-package. It supports different kind of scientific data format, for example, NetCDF, GRIB, HDF, and many others. And it has a variable class to do the data to get the data from the data fair, and also have the ability to read and write some scientific data site. And it has also an important sub-package is plotlib. It's quite similar with matplotlib with 3D plot ability. So it has some access classes and matplot module to plot for plot functions, 3D and 2D and 3D. And also has a geolib for GIS analysis, and has MeteoLib for some meteorological special field functions, and also ImageLib for, it's just briefly developed of this ImageLib. So this is the GUI of the MeteoInfo Lab. It's quite simple. It has one editor, for you can write a script here, and this is the console. You can write a command one by one and see the result. And also it's a figure pane. You can see the figure result here. Also, this is a fair explorer and a variable explorer here. And MeteoInfo Lab also can give you some auto completion of code functions, so you can it will be easy to write the code inside. So it is also a kind of IDE. It's a coding environment. So the point is multiple dimensional array from the data site. So you can create the data site or array from just write the code to create it, but in most cases it will be read from a scientific data site. It's I think maybe many people have experience with NCL. NCL has a function of add file. Also, in MeteoInfo Lab, you have this add file. With in this add file function, you can support many different data sites. For example, NetCDF, GRIB, and HDF. You can use just this add file function to get a dimension file object. So you can see the object information of this object. So you can see how many dimensions inside, and this is global attribute, and how many variables. It's a typical NetCDF data site framework. Each variable, it has which dimensions and what is the order of dimension, and also has maybe every variable has also the attribute also. So from this data file object, we can get the variable object. Just use the variable name, we can get a variable object, and from the variable object, we can get the data array. For example, this is the PS surface special. Surface special just has 3 dimensions. We can see here. The first one is time dimension. The second one is longitude, latitude. Third one is longitude. So we can fix the first one, the time dimension. This 0 means we can get the first time data set. The other two, just like with this one, you can get the total dimension of the last 2 dimension. So you can fix this is a 3-dimension data set. So you fix the one, and you get a 2-dimension array from it. So you can see the value of the array. You can see here, and also because it's not just in NumPy. Maybe somebody used NumPy. It has ND array. It has dimension. You don't know how many dimensions you have array, but you don't know every dimension, the dimension value of the dimension. So it's in MeteoInfo Lab, it has a dim array. So you can see that every dimension has array value. So you can use dimension value to get the array data from the variable. For example, this is a Z, this has a 4-dimensional. So we fix the first, is first 10. You can see this is the heat, it's pressure. So we want to get the 500 hPa. So we just write 500 here. Also, this is the latitude extend range, and this longitude range, we can get the data from this kind of thing. So after we get the data from the data file, we want to plot it, do analysis and plot it. So it's very similar for Matplotlib and maybe also MATLAB. It has a figure here. Figure contains all plot elements. In one figure, it maybe have one or more axis objects. Each object have a plot area with a certain coordinate system. Maybe the coordinate system is different. It has a position parameter. It's so it's from 0 to 1. Left bottom is 0, and right top is 1. So from this position, you can see the position of the axis and the size of it. In each axis, it has axis x, y, and it has the plot element inside the title and many other things. For example, it's Python. It's Python grammar because it's developed by JSON. JSON is a kind of Python, but it's based on Java. Because MeteoInfo was developed by Java, so I use JSON as a script language. So it can this is defined a function here. You can a range means to create a one-dimensional array, and this another one, and plot just plot x, y, the scale of the line, and another x, y, the scale of the line, and you can plot many, and put a title, put the x label, y label, and the legend here. So it's quite easy to get this kind of plot. It also supports multiple axes. You can use position parameter to tell where is the position of the axis in the figure. Also, we have subplot and subplot functions to get multiple axes. This is an example of a bar chart. I use a bar plot function. I will not introduce detail of it because it's kind of language. So if you want to learn it, you should have to study hard, I think. So it also have LaTeX support. So you can write a LaTeX string. So you can get this kind of things. You can write the many math in it. It also supports multiple y-axis. So you by twin x function. It's same with Matplotlib. In fact, I derived the functions of MeteoInfo. I follow the function name and parameters of NumPy and Matplotlib. So if you have experience of Python, it'd be very easy to use this one. And if you have learned this one, it's also very easy to transfer to Python and MATLAB and NumPy. This is a scatter. So you have scatter. We have scatter function to plot it. Also have a pi function. It's a box plot. It's a polar plot. So normally it's a Cartesian coordinate system. This is a polar coordinate system. So to do this kind of plot, you can use XS function with a polar parameter set true. And this is an example of a Windows plot. In MeteoInfo Live, I direct a Windows function to plot Windows very easily. Also, for a two-dimensional array, it's normally used in meteorological society. So you can, this example, for example, first add field and get the two-dimensional field. And because I want to plot two axes, so we use subplot. This is a raw number, a color number. This is the first, and we just use counter to create a counter plot and label it and title color bar, and another subplot with counter F. Counter F means counter with field counter. So create this plot, and also am sure to plot this two-dimensional arrow as an image. So it's also very easy to plot the data in a map. You use access m, add m character after access. This function creates a map access with the projection of longitude and latitude projection. And we can add a shape field as a layer inside with the shape read function, read the shape layer as a layer, and geoshoe to put it inside the map access, so we can get this map. Then we can, this PS, we just got it, it's a two-dimensional array. We use counter F. In map access, most functions has m characters at the end. So it's a counter Fi. It's 20 means 20 levels of the counter. So we get this map, this plot, and also take title, X label, Y label, and color bar. We got this plot, and we can save it. Use save figure function to many image formats. For example, also support EPS and PDF. Also, there are some special functions for meteorological data site. For example, to plot the vector, a streamline. This is a weather phenomenon and a station model. So you can write very complex script to do data analysis. There's some examples. For example, this is EOF analysis to see the El Nino and La Nina pattern of this area. Because it supports HDF data file, so it can read and plot satellite data very convenient. This is SWOT data. It's AOD data from Fengyun satellite. Fengyun satellite is issued by CMA. And it's Himawara. It's come from Japan. It's a very high resolution stationary satellite. And this is a Calypso. I think it's Calypso data site plotted by MeteoInfo Live. It also supports the three-dimensional plot functions. So first, you just create a 3D axis with axis 3D function, and use this. It's a plot function and many other functions. Also include scatter, counter F, shoe, plot surface, plot wireframe, and plot layer to create a 3D plot from the data site. There are some other examples. For example, this is a back trajectory from a high-split 3D data site. So another demonstration, we can try some high-split data set just we used before. So in MeteoInfo folder, you can see there's a MeteoInfo live.exe. You just double click it. If you are in other kind of operational system, you use other things to open it. Because it will load some libraries when it starts, so it's a little slow for start it. So there's some example here. First, we can show how to plot ARL data file. So we write script here, and we run with this button. So first we use add file to open. This is the data file used by cap text. So we have a data file object, and then we get the variable object, and then with dimensional setting we get the array, two-dimensional array, and then we plot it. First we create a map access, and with geoshoe. Geoshoe is country. You can see in MeteoInfo folder there's a map subfolder. There's several shape files, so you can just write the shape file without the .ssp. The software will read this folder to find the shape file. So country means the country.shapefile to open this as a layer, and then we could plot this two-dimensional data set as a field counter with counter fm function with 20 levels. So after we create the field, we use the field functions get 10, the first 10, because we use the first 10 data set, so we can get so every one object you get, you can write it in console and to see the value of it. So it's a data time object of Python data time object. So you can use to convert it to string and put it in the title. So just like this, and with color bar, you want to color bar this layer and add a label h bar here. So that is script. And after you run the script, you can get this is a variable explorer. It creates some kind of a variable here. For example, it first create a data file object, put it, you can see the information of this data site, file name, the 6 dimensions, and 11 variables, and each variable, the name, and the dimensions of it. Okay. So, for example, if you put if object and put a dot, you can see the functions of f object here. For example, you can use the PLJ. You can see this. Because the add field will read the data file object. The data file object including the projection information of it. So you can see this is longitude latitude projection. And after we create the PR, we can see the value of this two-dimensional arrow because it's too long, so it's not show all data here. You can PR dot for example, to see the average of it, maximal of it, shape. You can see the first dimension length is 25, the second is 39, and something else. So we can clear all variables here. So after that, you write f. The software don't know f what is object of f because we have cleared it from the memory. So also we can run the script. We just select one line and right click it, evaluate selection. So we just run the first line of it. So we get the f object. So we can use it again. So something like this. So we got this one f. So if we run all of them, just like this one. Okay. Another one to plot trajectory. Okay. So we can float it from here. So in this script, first we set the field name of the trajectory. We use the tutorial field here, and it's because the trajectory is a very special data field. So it's very different with the grid data set or station data set. It's not easy to use the NetCDF data model to describe it. So we use a special function add field / high traj function to open it as a field object and to get the trajectory layer from this function and the trajectory start point layer. And then just create a map object, create a map access with the position, because we not just plot map, but we also plot the vertical. So plot the country shape, and this is the trajectory layer. We just show it because we have created from this function. This is the start point of the trajectory. We can make a special symbol to it. And this is another axis. This is axis, not axis I, to plot vertical distribution. So with position and some other parameters, we could get the variable date. This is a column index of the trajectory endpoint date. The 12 means I think it's pressure output from high speed. So after we get it, we just plot it with the same legend as this one. So X label, Y label, something like that. Okay. Also for trajectory, we have 3D plot function. Okay, we can make it maximal. So we can select this button and can to rotate it to see the detail 3D information of the trajectory. So for this script, it's similar. We add field trajectory to get the trajectory layer and the trajectory start layer, and we read the states, the US states shape layer. And for 3D plot, first we use the Access 3D to create a 3D access, and use plot layer to plot the shape fair layer. And so to zoom it to the X limitation, Y limitation, Z limitation, and the title. So it's quite easy, not so complex to get this kind of figure. And another one. So another one use the NetCDF data file. It's relief data. So we read this is two-dimensional data, and to plot it, so we can see the relief in United States. But it's a fly. It's fly, not three-dimensional of this one. Okay. Also, I found that in CapText we have flight data site. We can plot it in a map also. So in this, we can use this button to zoom in, zoom out it. This is a data site of from flight. The background map from I think it's a Google map. It's Bing satellite map. So it has a read table function to read the text field with row and column. So this is field name, and the first line is headline. We don't read it with a format. So I means the integer, and it's a float, and this is a string. So after that, we get a table. So we can see table, the first 5 line of table. So we can see the column name, year, month, something else. So we get the longitude from this light, and latitude, longitude, and get the concentration from this column, the column name. And then we proxy it. We first also create a map access, but this we have a parameter. This it means it's a Mercator projection, because we want to use the background of Bing satellite map. It's a Mercator projection, and we use the web map function with provider. We can change different provider. For example, just Bing map without satellite. Okay, like this one. So in tutorial maps, we also have states shapefile. So we can use the scatter M to plot the scatter of this data set, because it has the longitude, latitude, and the concentration. So that's it. And it's trajectory calculation. How about 10? How many minutes left? I think. Okay. So because this is Python, this is just a Python script. So if you want to calculate trajectory in Python, you can use this kind of software. The point is to write control file by program. So you get the control file and it writes the parameters here, and use the OS system and you use the high-speed execute file to calculate it. So I don't want to talk detail of it. Also, you can calculate for example, 3 months or 1 year trajectories with this Python script. Use some loop. This is a trajectory with multicolor. Oh, no, not this one. Okay. Oh, this is for concentration, I think. It's similar with concentration. Is similar with ARL data format because it's also grid data size. So we can see the data here and the field. So this field has the variable of SO2 and SO4. Okay, in this website, there's some examples, MeteoInfo Live examples. So you can see the plot types. For example, error bar, you can just copy it. Okay. And make a new script, paste and run. You can get the result. Should be same with the website. There are many, for example, latex. We could try it. Okay, got this one. And also it has a document of MeteoInfo Lab. There's a user guide, but it's very simple. It's not complete because I have not so much time to do it. So it's introduce the GUI of it and plot tutor. So if you're interested, you can read this. It will be good for beginning of this software. So it's the error. You can create error, use the command with a 2-dimensional error, and you could create real 0 1-dimensional error like this with different with special data type and line space. Something you can do array indexing, slicing, and iterating following this instruction. And also it has this site tutor. So I think this one is useful if you want to read and plot meteorological data sets using MeteoInfo Live. It's a good tutor to follow. First, it's similar. First, to add file, to create a data file object and see the information of it, get the data variable, and get the 2-dimensional array, and create map access and plot the meteorological data inside and make other things inside and save it. And also you can use different, can get different dimension of data. For example, 1-dimension data you can plot like this one. And this is a counter. This is a vertical distribution plot. And this is 10 with 10 step. And also other with the projections, special projection. Okay, that's all. I think I can stop here. I feel a little tired. I think you too. Okay, thank you. Do you have any questions? Okay. Okay, please. Okay. You have questions?
Oh, yeah, is it okay? Thank you very much. It's really powerful. With the Meteo lab, the stuff you're doing, the last part with Python, I'm having trouble getting started. Is the idea that you just copy some of the example script elements into the scripting area and create your own thing based on the examples? Or are we able to run some of your scripts? Like every time I try to run one of your scripts, it can't find the modules, and it doesn't know the path, you can't do anything. But I'm thinking maybe you can explain again just how to get started with this function.
Okay. So you can use the examples from the website, but for example, if the example do not read a date file, you can use it directly. If it uses a date file, maybe your computer has no that date file. So maybe this is a problem of. And another thing is that you should download the latest version, newest version of MeteoInfo, because it's a personal software. So I have no such much time to test it completely. So maybe it has many bugs, but I think most functions should be okay. So you can use the example here.
How does it know where to look for the functions? Like in all the scripts,
yeah, because
a lot of import and how does it know how to import and where to import the modules from?
Okay, you can see here it's a PyLab. All the code JSON code inside here, so you can use. Normally, I prefer to use Notepad plug. Oh, sorry, it's Chinese version. So you can see all the code here. Yeah. So mixed with different numeric, and this, for example, this is the multi-dimensional array. So you can see the functions, all the functions here, and also the normally used is mi num. Here you can see normally for each function it has a description of it, and you can also find here this document is MeteoInfo Live API, but it's not complete. It's just some things, but not complete. You can see some, for example, log space. There are some documents inside in the web, but it's not complete. So if you cannot find it inside on the website, you can see the original code. So also here, because when the software starts, it loads some libraries packages. For example, it has load numeric as NP. It's very similar with NumPy. So you can write NP dot. You can see the functions here. So you can use the functions, and also PLT dot. So many functions plot. I know it's not so good for documentation of this software, but it's manpower. Should have manpower for it. Okay.
So just before you leave, I think we didn't introduce him properly yet. So actually, Dr. Jiaqian Wang came all the way from Beijing here to give this presentation. He's a longtime collaborator of ARL. Actually, we met like what 10 years ago.
Yeah, 10 years ago.
When he went to do a postdoc work at the University of Huelva as part of a collaboration. University of Huelva in Spain, as part of a collaboration between ARL and that university. He produced a lot of work on dust storms and Saharan dust and global dust. Currently, he is actually the director of the Institute of Atmospheric Composition as part of the Chinese Academy of Meteorological Sciences. So we are really proud and very glad that he could make it here. And of course, he's going to stay until tomorrow. So if you have any questions, you can ask him those questions. He has developed most of these tools by himself. So he's very well versed on programming, and he's very brilliant in doing this work. Okay, so I just wanted to highlight that we are we're very happy to have Jiaqian here